radiata or interlobular structure up here. This would be the interlobular, arcuate, cortical radiata coming up. Okay. Now, once it actually comes up to here, which is basically coming up in here, it turns into arterioles that go into the nephrons. So what you're looking at over here is a nephron. This nephron is higher, so it's cortical. This nephron is lower, so it's juxtamedullary. Two different nephrons. You'll see that the cortical nephron loop doesn't go very deep. The juxtamedullary loop goes significantly deep into the medulla. That's how you tell the difference. Once you get to this level, you can actually see where the arteriole comes into this structure right here. This is the renal corpuscle. This is an example of what the renal corpuscle looks like. Now, the renal corpuscle and these tubular structures make up a nephron. The renal corpuscle is made up of a glomerular structure, which is a capillary bed, and the Bowman's capsule or glomerular capsule, which is basically a round tubular structure. Once the actual blood flows through, it comes in through an afferent arteriole, goes to the capillary bed, comes out through the efferent arteriole, and goes on its way. From here, the filtrate is taken out down into this structure, which is here. And this is the proximal convoluted tubule that goes into the descending limb of the loop of Henle, comes up the ascending limb of the loop of Henle until it gets to the DCT, or the distal convoluted tubule, jumps into a collecting tubule to a collecting duct, and it takes the urine all the way down to here, which is the renal papilla, this end area here, and it dumps the urine into the minor calyx and goes out the usual process. Some of the more detailed aspects is you'll see that the red here is without the visceral layer. The yellow here, it has a visceral layer, so this is the actual visceral layer within the glomerular structure, and this is this purple out here is the parietal layer on the outside. This is the PCT, just like that, because it's proximal to that, and this is the DCT, which is further away. But you'll notice that the DCT comes very close back to the renal corpuscle one more time before it exits. That's what this is. So this is the distal convoluted tubule, this is the proximal. Inside the distal convoluted tubule, on this side right here, you have something called the macula densa. The macula, if you turn your page, go back a little ways. The other way. No, go deeper. Keep going. There it is. What page is it?
702.
On 702, you'll see a picture of the macula densa. It's called the juxtaglomerular complex or apparatus. You see it? That's 702 or thereabouts. So here's the DCT. Here's the macula densa, and then right over here is the representation of the mesangial cells that make up part of that juxtaglomerular complex. So this is outside Bowman's capsule, inside glomeralis. Together they make the renal corpuscle. This whole process through the tubular structure is to filter the actual filtrate, reabsorb that which was important for the body, and excrete that which it doesn't need into the collecting tubule all the way down and urinate it out. Now you need to know something called peritubule capillaries, and you need to know from your lab the vasa recta. So if you turn back a little bit, like the 701, 700 maybe, let's see, right there, 701. On the bottom right of 701, you're going to see something called the vasa recta and the peritubule capillaries. You see that? All right. So the vasa recta is this area right here. It's the area that's, if I were to take this and superimpose it over here on the actual tubular structure, that's the vasa recta. Up in here is the peritubule capillaries. You just take that and you put them right over here. Now they don't have them over here because you wouldn't be able to see the actual tubes. So the peritubule capillaries look like they're going around the renal corpuscle, the DCT, and the PCT. The vasa recta looks like it's actually going around the loops of Henle. So that's how you notice the difference. Can you see that in your text? That makes sense. All right. And generally speaking, that's all this plaque has to say. But there's a lot of information on here, and they can They'll have at least one of these out, sometimes they have two. Because it's very detailed, yes.
So the point of part of the nephron extending so far down into, was it the pyramid?
Medulla?
Or the medulla? Is that just part of the filtering
Yes.
mechanism?
They each have different functions. The cortical nephron is shorter with its loop, so it's gonna actually filter different types of items. The long loops of the juxtamedullary are going to actually, the filtrate's gonna spend more time in there, so it's actually gonna create more filtration, either more filtration, reabsorption, or secretion. So the longer the loops, the more detailed and more efficient the actual filtration is going to be. Okay, there you go. That adds